All right, this is our video for Friday, April 10th. On this video, I'm going to review the tangent line packet. I realized in preparing for the video that I really need to do two separate ones so we don't have one that's way too long. All right, so on the review of the tangent line packet, I worked several of these this morning in our Zoom, but we still had requests for a little bit of discussion. I want to talk about number 30 first. It says that they want you to find f prime of pi over 3. So the first thing you would need to do is find the derivative, and then remember that you would then plug in the pi over 3 and just remember your tangent. Now on your derivative, it is a fun problem. You need to remember to use the chain rule, and you'll also use the power rule. And I'm going to put out the answers to these tomorrow so you can check your work. That is a really good problem to remind you of how to do the derivative. On number 31, we talked about this one this morning, and this is 2 to a power. And again, they're wanting the equation of the tangent line. Remember that you would need the slope of the tangent line or the derivative at -1, and then you would also need to figure out your point at x equals -1 by plugging those in, but you've got to find your derivative first. And so we got out our orange paper, and you want to look at the derivative of a to the n and use that on that problem. The 32 through 34, it was talking about finding the slope of the tangent line. So again, you're just finding the derivative and plugging in. 33, the normal line. Remember that the normal line is perpendicular to the tangent line. So you want to plug in, figure out what the slope is at the tangent line, and then the normal line would be the perpendicular. 34, same thing. For what you want to find the derivative first using your calculator, and then you can answer the question using your calculator. On 35, we worked this one this morning, and it took a lot of thought, but it was good thought. It probably wouldn't have taken us that much thought back in the fall. But really on this one, you have your point, -3, -2, your point of tangency, and you have your slope of the tangent is -4. And so you need to find your tangent line. And then it's basically asking for approximation of f of c, where x equals c means that the y is equal to c. So really you just get your tangent line and you plug c in for x and c in for y and figure out your answer. And I'll leave that one for you. The other one that we worked this morning was number 38. And that one was a good one as well. On 38, the easy part was finding the derivative of the y equals. And then you had to use your equation of tangency to find the slope of the tangent, and then you want to set them equal to each other. But just be sure you answered the question. That was where I made my mistake. And then this morning we also talked about number 41. And on 41, we determined that it was pretty difficult and we didn't quite understand all of it. It is good practice for you to find the approximation, but as far as their answer, you can look at it. And we understood why that the answer had to be greater than 57. But we weren't really sure why it said it had to be smaller than 63. So if somebody can figure that out and let me know, and I just realized you can't see any of this stuff, let me know on that. Again, terminology and just kind of getting your brain back thinking about derivatives and tangent lines is why I gave you this one. Liked 35 just because of all the thought process that we had to go through. So give it a try if you haven't. Again, I'll post the answers for tomorrow, so take a look at those, and I'll be in Zoom, and I will make a video about the related rates next.